Welcome to the second video for section 3.1. In this video, we are going to be graphing lines. Let's start with vertical and horizontal lines. If the equation contains an x but no y, so it has an x in it only, and then of course a number or possibly more than one number, it will be a vertical line. If the equation contains a y but no x, it will be a horizontal line. Now, sometimes you may see f of x in the equation. Remember that f of x and y are interchangeable. So if it says f of x equals a number, then it is a horizontal line. Okay, so this first one, f of x equals -1. If you would like, you can go ahead and replace f of x with y. So y equals -1. Since the equation does not have an x in it, we know that this is going to be a horizontal line. That's something that you'll probably want to memorize or at least put on your sheet of notes for the test for Unit 3. So all you have to do to graph it then is go to the y-axis. Since it says y is -1, go to the y-axis, go down and find -1. Now if you want to put a point there just kind of as a placeholder, you can, but realize that this is the graph of a line, not a point. So if you only plot a point and that's it, then it is incorrect, okay? So what we want to do is at -1 on the y, we are going to draw a horizontal line. Put arrows on the ends. And if you wanted to label it, you could label it. I will not require that you do that. But it should make sense to you that this name of this line is y equals -1. Because if we were to start naming ordered pairs on this line, they would all have a y-coordinate of -1. So, for example, this point here, 1, 2, 3, 4, is -4, -1. This point here is -2, -1. We could come over here, let's do this one. And we have 1, -1. And we could just keep going on and naming points on that line. And every single point would have the y-coordinate -1, which is why the line is called y equals -1. Horizontal line. Okay, number 2. When you look at the equation, it has an x in it but no y. So because of that, right away we know that this is going to be a vertical line. However, to figure out where to place the vertical line on the coordinate system, you do need to go ahead and isolate the x. So add 12 to both sides and divide by 4. So x equals 3. Then we're going to look at the x-axis. We're going to go to 3, 1, 2, 3 on the x. And again, if you need a marker, you can put one. You don't have to put anything at all there. What you have to do is draw a vertical line at x equals -3. X equals +3. So we draw the vertical line at x equals 3. So every ordered pair on that line would have 3 as its x coordinate. So those are pretty easy to graph. Just make sure you know by looking at the equation whether it is vertical or horizontal. And remember, that only happens if the equation contains only one variable. If an equation contains both a y and an x, it will be a slanted line. And there are a few different methods for graphing slanted lines. We're going to start with the Slope-Intercept Method. Step 1 is to put the equation in slope-intercept form. Sometimes it will already be given in that form, but if not, then you will solve it for y. Once it's in that form, you can see what the y-intercept is. So step 2, plot the y-intercept. Step 3, use m equals rise over run to get more points. And you can get as many more as you want, or maybe I should say as will fit on your coordinate system. If you have a positive slope, for the top number, you can move up or down. Negative slope, you can move up or down. But once you move up or down, what you do as far as your run depends on whether your slope's positive or negative. So if it's positive and I choose to go up for my top number, I must go right for the bottom number. If I go down for the top, I have to go left. So think of this. Up is a positive movement, right is a positive movement. A positive divided by a positive equals a positive. Down is negative, left is negative, and a negative divided by a negative equals a positive. Now, let's just say this point here is our y-intercept. If from that point I go up and right and put a point, or down and left and put a point, and then I draw a line, notice that the line rises. And when you have a positive slope, that's what the line does. It rises. So you can use that as a check. Okay, for negative, let's think again. Up is positive movement, left is negative. Down is negative, right is positive. So a positive divided by a negative or a negative divided by a positive is going to give you a negative slope. And let's see what happens here. If this is my y-intercept, and from that point I go up and left, or I go down and right, it will cause the line to fall. And again, you can use that to check. Look at your equation. If it had a negative slope, when you finish graphing, make sure your line falls. So let's practice. It says, give the slope and y-intercept of each line, then graph the linear function. So number 1, first of all, check to see if the equation is in slope-intercept form. And it is. Y equals mx plus b. Okay, so then we're going to answer this part. Give the slope and y-intercept. Don't forget to write that down. So we're going to say m for slope equals 1/2. M is the number in front of x. It does not include the x. Okay, so when you write down what the slope is, don't write the x, just write the number in front of x. And then the y-intercept, and if you want, you can just put b for y-intercept, is -2. Or you could write the y-intercept is -2. But do not write y equals -2. We don't want to write that because that's an actual line. As we looked at the beginning of this video, that would be a horizontal line. And we're just wanting a single point there for our y-intercept. So let's not write it that way. You can write it as b equals -2 or y-intercept equals -2. So to graph it, we will go to -2 on the y-axis. Put a point there. So anytime you're using the slope-intercept method, the very first point that you plot should be on the y-axis, never on the x. Okay? Whatever this number is here, you go to that number on the y-axis. Now, we want to get more points to make a line. So then we come and look at our slope, 1/2. It's positive, okay? So here are my choices. If I choose to go up 1, it's positive. If I go up, then I would have to go to the right 2. Now, I could also make the choice of going down 1. If I go down, I have to go left 2. positive, you can go up and right, or you can go down and left. So from the y-intercept, I'm going to go up 1, right 2, and put a point. And as soon as you plot that point, think about, if I were to draw the line now, would it rise? Because remember, a positive slope should rise. If I made the mistake of going up 1, left 2, and I put the point over here, if I checked right then and said, would the line rise, I would be like, oh, no, it's not rising, it's falling. I must have done something wrong. And then I can go back and figure out how I need to fix it. Okay, so up 1, right 2, and you can actually continue doing that same movement, up 1, right 2. I usually go ahead and do it as many times as I have room. And I also like to do the other way, down 1, left 2. Back to my y-intercept, down 1, left 2, down 1, left 2. The more points I plot, the more accurate my line will be. Now, I would suggest you use a straight edge then to put up next to your points. Go draw your line beyond the points and put arrows on the ends. And one more time, check to make sure, since you had a positive slope, that your line raises. From left to right, it goes up. Okay, so that's a basic example of using the slope-intercept method. Let's try another one. Remember, f of x is interchangeable with y. So when you see the f of x, you may want to go ahead and just rewrite it with y. Now, then you might be tempted to think that this is a horizontal line, but it is not, okay, because it has an x in it. It has a y and an x. If it has both variables in it, it will be slanted. It is in slope-intercept form. The slope is the number in front of x, so the slope is -3. Now, if I just said, tell me the slope, you could just answer right like that, m equals -3. But if I say you're going to graph the line, then you're going to need a rise and a run. So if your slope is not in fraction form, put a 1 under it. Now we have a rise number and a run number. Okay, b, the y-intercept. Well, this is mx plus b, and we do not see a number in the b position. Then that means b is 0. So on our grid over here, we start at the y-intercept, which is 0. Put a point there. And this time our slope is negative. Now I can still choose to go up 3. But if I go up, I have to go left 1. Up and left is going to cause me to draw a point that will make the line fall. Or another way to remember it is, if I do a positive movement, I've got to do a negative movement so that my slope is negative. So if I choose to go down 3, then I would have to go right 1. And again, I like to do both just to get as many points as I can. So back to our y-intercept, I'm going to go up 3, left 1, and put a point. And I don't have room to go up 3 more, so that's it. And then I'm going to go back to my y-intercept and down 3, right 1. And that's all the room I have is just for those 3 points. So take your straight edge. Sorry, my lines are not very straight. And put some arrows on the end. And then remember to check, we have a negative slope. And the line should fall. It should go down from left to right. Now this is a pretty steep slope, but it does go down. It falls. So we've checked that. That part is good. Okay, let's do another example. We're still using the slope-intercept method. However, this equation is not in slope-intercept form. So our first step is to get it into slope-intercept form. So to do that, I want this y term to stay on the left side. I'm going to subtract the 4x and add the 12 to move those over to the right side. Now to get y by itself, I would divide every term by 6. So now I've got y equals. Simplify your fraction would be a negative 2/3, and that x still needs to be there, plus 12 divided by 6 is 2. So now we have the equation in slope-intercept form. Let's write down the slope, negative 2/3, and let's write down the y-intercept is a positive 2. So when you get ready to graph, you're going to go to your y-intercept. So we're going to go 2 on the y-axis. Now our slope is negative, okay? So you don't have to write out, like I have been on the first two, your movements. Just in your head say, okay, I've got a negative slope. If I go up 2, I have to go left. I have to do a positive and a negative movement to equal a negative slope. So up 2, left 3. Or I can go back to my y-intercept. I can go down 2. Then I'd have to go to the right 3. And then I'm going to think about, okay, the negative slope should cause the line to fall. And I'm going to think before I even draw it, does my line fall? Yes. Okay. So always check that. If it's not rising or falling like it should, then you made a mistake in your right and left movements. Okay, take your straight edge. Draw your line beyond the points and put arrows on the ends. Okay, so that is the slope-intercept method. We are going to look at one other method in this video. Now, remember, we also looked back in Unit 2 at the point plotting method. And so that's another way to graph lines, is just to make a table of points, plot the ordered pairs, and draw the line. But here's another method that I like to use in certain cases. It's called the intercept method. Okay, it has nothing to do with the slope at all, just the intercepts. Okay, step 1, put the equation in the form ax plus by equals c. So that means you want your x and y terms on the same side, your constant on the other side. Step 2, find the y-intercept by letting x be 0. Because anytime x is 0, the y value of that ordered pair is going to be your y-intercept. Find the x-intercept by letting y equal 0. And for steps 2 and 3, what I usually do is just make a little table like this. When I want to find the y-intercept, I let x be 0. When I want to find the x-intercept, I let y be 0. I just find those values. And now I have both points that I can plot and draw the line. So let's try it out. Use intercepts to graph each equation. So make sure that you read the instructions carefully, and when it says use intercepts, then we don't want to write it in slope-intercept form. We don't need to know the slope, okay? So again, make sure you put these instructions with the method that we're about to do. So step 1 was you want x and y on the same side and the constant on the other side. Then you're going to find the intercepts. And so, like I said before, I would just make a table, put 0 in for x, put 0 in for y. Now this method works nicely whenever the constant is divisible by the a and b, which it is here. Okay? If it were not, I probably would not choose this method. if I were doing a problem where it gave me a choice. Okay, so if I let x be 0, that's going to get rid of that 4x altogether. So you could just cover that 4x up with your finger and then look and see, okay, I've got 6y equals 12. If I divide 12 by 6, I'm going to get 2. So it is possible to complete that ordered pair without even writing down any work. However, if you need to show the work, that is certainly fine as well. So I'm going to come down here and show you what it would look like if you need to show it. So for the y-intercept, I would let x be 0. And 4 times 0 is 0. So then it would just become 6y equals 12. And I would divide by 6 and get y equals 2. And that 2 goes in this spot in the table. However, I would still write it as an ordered pair. I don't want you to get confused and think we're going to go to y equals 2 and then, well, let me finish the x-intercept and I'll show you what I mean here. So the work for the x-intercept, I'm going to let y be 0. So 6 times 0. So that 6 times 0 is 0. You would get 4x equals 12 and x equals 3. So that 3 will go in your table. The x-intercept is 3, 0. If you don't write those ordered pairs down and you just look at y equals 2 and x equals 3, you might be tempted to plot a point at 3, 2. And that point is not on the graph. It wouldn't help us at all. It would only be a single point, which is not enough to draw a line. So don't get confused and put those together as a point. We have the y-intercept is 0, 2, and the x-intercept is 3, 0. Those are the points we need to plot. So again, you do not have to show this work that I've shown here at the bottom. You can just fill in the table if you're comfortable just doing it from looking at your equation. Okay, so let's plot 0, 2, and 3, 0. Now this method, you are only going to have 2 points, and that's okay. We're going to still draw the line, use your straight edge, and still put arrows on the ends. Now, since we didn't find the slope, we are not able to check the rise and fall with this method. Let's try another one. Okay, so remember the first step is we want x and y on the same side, constant on the other, so we're going to subtract the 15. Make sure you get that negative sign on there. Okay, now we're going to make our table. 0 for x, 0 for y. And I'll go ahead and write it out again in case you need it. For the y-intercept, I'm letting x be 0. So 3 times 0 minus 5y equals negative 15. And then 3 times 0 is 0, so negative 5y equals negative 15. And if I divide by negative 5, I will get a positive 3. So my y-intercept is 0, 3. For the x-intercept, I'm going to let y be 0. So 5 times 0 is 0. Now it's going to say 3x equals negative 15. And if I divide by 3, I get negative 5. So my x-intercept is negative 5, 0. Let's plot 0, 3, and then negative 5, 1, 2, 3, 4, 5, negative 5, 0. And draw the line. It was not very good. Let me try that again. Don't forget your arrows. Okay, so this is the intercept method of graphing. We still need to talk about parallel and perpendicular lines. I'm going to go ahead and make that a separate video. So I'm going to stop here, and if you want to go ahead and do the graphing problems on your homework, you can do that from this second video.